Hi my friends, today we model this part which has the name box punching machine body because it is the body of a machine. The source is from Timoteo Carrera Soto, and this is the machine and this is the part which is our target today. You see there is a thread, here you see better, which now it is not in the standards. So you can use my tutorial number 334 if you want to create a real thread. We'll use conventional thread here, which is trapezoidal. This part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182. This is my drawing, and this is the conventional thread, which is in actual standards. We see here some interesting elements of this part, and I suppose we have here all the dimensions needed. We start with this feature, which has the thickness of 6, as you can see here, and dimensions all over. I don't mention that dimensions, but I start the work, my friends. Sketch in the plane XY. We start by drawing a vertical line starting from the center point. The length is 69 plus 58. Dimensions in the drawing. I move this dimension to see here better, and I draw lines not from the center point but from here. I keep pressed the left button, I go up, again up, left, down this level and back. Dimensions 8 is this, radius 12 here, tangent between these two 54, again 54, and again 54, my friends. All these dimensions are in the drawing. This is 34. One dimension is missing. What is that? I don't get. Let's see. This angle. But we don't. Let me apply this to see what happens. 40. Oh, I know what is. Control Z with this angle. There is another dimension here, 84. We have a fully constrained sketch, but we didn't end the problem. We have to apply a fillet of 33 here and another one of 22 right here. And this is not all, because we draw also a small contour. Keep pressed the left button, go down, keep press the left button and go right here. These two are equal, and this dimension is 25. This is 69. This is 69. This is 27. And the radius is 7. The last dimension to apply, 7. We also apply a split. This point and this point. Why? Because I make this construction line and we have a full contour, unique one. I don't split this small line because it is not part of this contour. If I leave this line a normal line, we must select which close contour to select from, this one, or all of the contour. Finish sketch, F6, extrude. You see, the unique contour was selected automatically. Symmetrical on 6. Good. Now we want to apply this, let's call them ribs. You see here better. This, and also this. You see, the section is 20 for this and also 20 for this. The third one is 30. All have a radius 3 as the end of the contour, radius 3. We create slots, my friends. We select this plane. We select this slot center to center, and we draw a slot in the air. This is 30 minus twice 3 as a length, and 6 as the diameter. If you want to be very rigorous, you write here twice 3, but in the drawing we have the radius, the dimension 6. You see here 6. This is why I admit to use 6 as the dimension, because it is in the drawing. Then I make coincident this point with this center point. Finish sketch. Now I apply sweep. I select this contour and one of these two curve. Go to the next, because we have only one close contour, but here you can see there is also this, and the edge is this one of the two. Okay, very interesting. This is 30, the others are 20 minus twice 6, of course. I select this face, I create a slot with the horizontal 20 minus twice 3, then 6. I place this point over this, finish sketch, sweep, I select this, not this. Then the curve is this. Okay. The last one is this contour. Once again, we select this face, we create a slot, the same with the previous, 20 minus twice 3 and 6. I place this point over this midpoint, finish sketch, then sweep on this contour on this path. Okay, next is this revolving object, and also this, because they are concentric. Yes, we have here all dimensions, so we just start. XY plane, F7, we project only 2 lines, this one, not 2 but 3, and this one. Then we draw a center line, and we create 2 closed areas. This one and one. I keep pressing the left button, I go somewhere here, then to the left, down and back. Dimensions, this is simple, 10 multiplied by 2. This one is 4 millimeters, radius. This is 45 and this 54. Once again 54. One dimension needed. Which one? I don't see. Maybe this one? Yes. Collinear. This with this. Finish sketch. Revolve. We have to select the two closed areas. The axis is known. Okay. Another revolving feature is this one, which has radius 4 at both ends, and dimensions are here, 34, 42. If you add twice 4, this 4, to 34, you find 42. This means that this line contains the center of this arc. This is why I suppose we don't place this dimension or this dimension, because this is already obtained. Let's see. Again, XY plane, F7. I project only this line, small line. You see here, I project this arc, this. Then I draw an axis, center line, from this point to the left at a dimension of 64 minus 8. Then not center line, but simple lines up. I press the left button, I go straight to the right, then here and close. I make equal these two arcs. I make them placed on the same horizontal. Then dimensions, this is 4, this is 34, and we have a fully constrained sketch, so that we don't need to apply the other dimension 42. Finish sketch, revolve, select axis. You remember we have a small line here. It is necessary to select an axis. Okay, next is this extension with dimensions here, 35 from the bottom, 28 from the left, from the axis, radius 10, and diameter of 10 for the hole. Let's create this XY plane, F7, line to the right, press the left button, go back 180 degrees, back to this line, and placing this line on the center point. Dimensions 28 from this arc to the vertical, radius 10 and distance of 35 from this line. 35. Fully constrained sketch. Finish. Now let's see what is the distance. The distance is 37. Then I'll place this cut of 5. 37 is the extrusion, symmetrical, and 37. I select this face to draw a rectangle, this, then to place this center point to the center point, to the center of the circle. I make this as a construction. I project this generator. I make collinear these two, and I apply 5 as the only dimension. But why we have this? Because there was this circle which I delete, and now I suppose we can modify this to be 5. Finish sketch, cut, extrude with cut to this face. Okay. If you consider the technological flow, you understand that this must be created after the hole here. But it was easier for me to use this procedure. Let's apply the holes. You see, there is a hole of 35 up here, a metric 10 here, and a 10 millimeters hole here. Good. Hole. Now is already selected the metric 10, so that I select this face and this center. Plus. Now I go to not threaded line with a diameter of 10 to be placed on this face with this center through. Okay. And the last is that of 35. This face, this center, not through. Let me place the diameter of 35. You see, I cut it here. I double click the last feature, and I apply 2 because this comes to this face. Okay. Another hole is this one. I told you that this is trapezoidal 24 with a pitch of 3, because the square thread is not usual, but you can use that tutorial number 334 to see how to create that square thread. I apply hole, this face, this center, thread it, isometric file, not isometric, trapezoidal threads, and the diameter is 24 with a pitch of 3, not other pitch, 5 or 8. 4 doesn't exist in current standards. And the hole is through. Okay. I suppose that's all. We only have to place fillets. You see here, undimensioned fillets are radius 2. There is placed here one of them, and the rest are also 2. Let's apply. I select this for a fillet, and you see we have all this contour. I go up here, here, and here. Also this on the other side. This and this. This, another one is here, other fillets, and I suppose that's all. Okay, now I see that there is a wrong construction here. And you see what is the difference? Do you see? Yes, professor, we see. This is outside, not inside of here. Our lucky business is that this is a parametric software, Inventor, so that we can modify anytime this. This feature is not this, yes, this one. We must modify the sketch. F7, I eliminate this constraint and also this one in order to modify this. Yes, we have another dimension here. What dimension? 64, not the one from before. 64 is this distance. 64, and we draw a line. We cannot extend this because this dimension is already placed, so I draw a small line here and I trim this. 2 dimensions needed. What dimensions? Let's see. Or constraints, apply. This is the problem with this point. Remove, done. It was this small sketch. Delete. But I have to place this line as a collinear one with this one. Now we have a fully constrained sketch. This is a center line, so that we can go back. Now we eliminate this because it's too short. This is to be delete. Okay, with the sketch, and we apply again whole, which has everything remained. The face is this one, the center is this one. Okay, now we have a good solution. Let's see what about the volume. Eye properties, physical, update, copy, close, double click, paste. There is a small difference. Maybe some fillets are wrong, but what you have seen here is all we done. Let me apply material, steel cast, then the aspect I want to be gunmetal antique, and to apply a few faces to be machined. This one I keep pressed the shift button to select only these three faces. And a cut. I keep press the shift button from the keyboard, again keep pressed, and apply titanium polished. I like this combination. Eventually you can change the visual style as shaded. Now we don't see. Oh, this hole is also machined, of course. I select it, I go here, I apply titanium polished, and now we don't see differences. That's all for today. Thanks for watching. Bye bye.